So I'll be talking a bit about programming, and the central theme of this presentation is about creating packages, but we'll cover a lot of topics along the way, including things like modules and debugging. Somewhere around the midpoint, I'll show you a short package that was created as part of the art gallery thing, and there's kind of a funny story related to that. So maybe stick around for that. So let's jump right in. The first thing with programming that I recommend these days is to do your programming in something called the code edit region. So I hinted at this, I think, in the Q&A session. And so one thing to remember is that it's Shift Enter to enter new lines, and it's Enter to execute. You can put comments in here and they show up in a different color. And if you start doing some coding with constructs like an if and whatnot, you'll notice that we do have some syntax highlighting here going on. So if you look over on the right of this window, you can see that there's certain properties here. I can, for example, turn off the line numbers and maybe remove the border. So I can get a really clean looking document if I'm concerned about that. So let's let's jump right into writing some real code. So let's start with the procedure. So my POW, let's keep it really simple for everybody. So this is going to be a procedure with two parameters, A and B, and it's going to return A to the B. So now when I execute this, that procedure is defined and I can call it in my worksheet. So 2 to the 3, for example, and I have 8 there. I could also put that call right in here. Let's do a different input, and I might as well do some other stuff in here just to show you what's going on. So I've defined my procedure, and when I press enter, it executes all of these things and I get the output in sequence. I put a colon here, as everybody knows, to suppress output. Otherwise, I'll get my procedure echoed into the command line. So this talk wants us to lead into creating a package. So let's put a module around this. So a module is sort of a data structure that encapsulates data and procedures and is really the foundation for a lot of different data structures in Maple. And really all you do there is wrap module and module around something. And now that's part of a module, but in order to make it useful, let's give it a name. So it's warning me here that my POW is implicitly declared local because this package has a scope. So to indicate scope, we should properly indent things. So really, if I want to access this, I want to export it. So now I have a package, well, I have a module still, but I can call it. And if I can type. So the only secret to making it a package is to take a module and put option package on it. Now this is the magic that, so I can still call it as a short name, but now I can use the with command. And that has given me the ability to load it with the with command, and now I can use the short form and compete with that. So this isn't a terribly interesting package yet. I want to do some more with it. So let's expand the package to add some state, some local variables, and maybe another method. So let's let's have a local variable. Let's call it exponent. And I'm just going to set it to null as an initial value. Then I'm going to add another method, and this one I'm going to, let's make this exported too. And it's going to be called set exponent. And we'll just take one argument, and all I'm going to do is do exponent equals e. And I have made a mistake. Oh, if I equals proc. Okay, so now let's clear this up. So now I have a, well, let's load it again. So now I have a method called setExponent. And you can see when I with the package, there's now 2 exports that are listed. Exponent. And actually, if you can see that, there's a little tooltip highlight. If I hit tab, it will command complete. So when I with something, it adds it to the known set of completions, so I can fix my typing, my bad typing, and use that. So let's set the exponent 5. It doesn't do anything now because I haven't used this exponent variable anywhere, except that now it's assigned inside my module. And the scoping here is such that it knows that everything here is together. So this value gets stored and it saves and it persists through the session. So I'm just going to make use of that exponent. And I'll set a default value for this parameter b. And then if b equals null, then we'll just calculate a to the exponent. Else, we'll have the regular input. All right, so let's load this again. Now, if we set the exponent to 5 as before, we can call mypow, and I'll just give it 2, and it should compute 2 to the 5th. So really, that's a very rapid fire, quick intro. In 9 minutes, we've learned how to create a package. We've learned how to program a module, use code edit regions, and you're well on your way to becoming a Maple expert. But let's take it a step further, and we'll save it into a Maple library archive file. So you can do this using the library tools package. I'm gonna just, I've got this already pre-done into a special place. So Maple will look into the toolbox directory, subdirectory of your home directory. And if there's a package subdirectory and lib, it will find those and pull them in. So if you have some toolboxes installed, they might be located in a place like this. So we're going to take advantage of that. And I'm just going to make this directory first, and then I'm going to create the MLA file. So this is called mypack.mla. So let me just cheat, and I'll copy this line, and I'll go back to my original definition here, and I might as well throw it right in here. And I will call library tools save, and that's on my lib. Sorry, I wanted to save my pack into that library. So now when I execute that, I've defined my module and I've saved it in a special place. So if I go now and open a new worksheet, and let me zoom this in a little bit. I can do with my pack. And I have access to that. I didn't have to go open a file or load anything. All right, so that's how you create a module and you save it into a library archive. If you went into that directory we just created and picked out the mypack.mla, you could send it to a friend as well, and then they would have the advantage of being able to use your package as well. So let me show you a pre-constructed module. So I've already got this in a file, and I wanted to, so part one is done. We've created the module, we've saved it, we know how to create a package now. Let me show you an existing package, and I'm going to just show you this is being constructed in a slightly different way. Sometimes it is good to go outside of Maple if you have a favorite text editor to manage a large file that gets checked into a revision control system. You can do it this way. So I've already created this package, and I'm going to come back into Maple, and let's increase the zoom again. And I'm going to load that package using the read command. So this is, and I've named it in a .mpl file extension. So let's switch back there. So it defines the module, and then at the very end, it does the same thing. It's putting this, saving this into that same package MLA that we created before. And then it's also, for convenience, it's nice to do something in it that echoes some output. So I put a printf statement so that when I reload it, it changes the timestamp and echoes that. So this is a package that I've purposely made a mistake in doing something in. So I'll just try using this package, and then we'll get into a little bit of debugging. So, so with Mosaic, and then I need, so this is something that requires an image, and it's the same directory. And this is the Mona Lisa JPEG. Okay, so there we have loaded the image, and now we can create a mosaic. So it's going to take that image and split it up into a bunch of triangles with color samples. So we can do a couple of different styles of mosaic. And the next one is, say, style equals diagonal. This is where it's going to raise an error because I made a mistake on purpose. And so one thing to notice here is that it's actually giving a line number of where the error is. So if I go back to here and look at line 68, sorry, it was line 68, I see that the error happened somewhere here. It's not immediately obvious to me what that error was from here. So I'm going to use a magic command called stop error. And I'm going to stop at all errors. You can give it a specific one, or you can stop at everything. So I'm going to re-execute this command. And of course, the debugger window pops up on my second screen. So let's drag that over. So I don't know if a lot of people have seen the Maple debugger window, but this is extremely useful for stepping through code and investigating problems in some code. So the first thing we see is the line that we're stopped on, and actually it turns out that we're stopped in the polygon plot command. And we have a bunch of controls down here for doing various things as you would normally see in a debugger. But there's a lot more here. If I type help, I get a list, a short list of all the commands that are available. And some of these are present in these buttons, and some of them you can just type into this little line here. So one of those ones you have to type in is called where, and that shows me the current stack. And there's other things like I can call inspect and the stack level 1. Let's say what's T, and it shows me that that's what the value of T here is, which is the first argument to polygon plot. Since I'm in polygon plot, I can just type args, and that'll show me the arguments that were passed in. I can type in 1 + 1 if I really wanted to and do some computations. The debugger knows what scope I'm in, so you can access the local variables there. So let me also show you that some of these commands can be accessed from outside. So there's a command called show source. And I want to look at the mosaic command. So there's two things you'll notice here. You'll see the actual line number of each of the lines of code, and you can see the statement number. If you don't have the source code for a particular procedure, you'll see just the statement numbers, and you can use those statement numbers to set breakpoints as well. So I can do a stop at, and I can use the full line of the full path here. So let's type this in one more time. And I'm going to stop on line, say, 67. So now if I go back here and I execute this, sorry, that didn't actually stop there. Let me try this again. So there's I should get an echoing of all my breakpoints, so I know I must have made a mistake. Well, let's just stop at statement number 4. Sorry, mosaic 4, and now I get an echoing of that breakpoint. So if I go back and re-execute the code, my debugger window again shows up on the other screen. I'll pull that over. So now I'm stopped in a place here, and I want to look at what T is again. And I know there's something wrong with that because, of course, I made the mistake intentionally. So this should have been a procedure and not this unevaluated name. So let me get out of the debugger. I will go back to my code source, and I will fix the problem. So I had made a spelling mistake here, and I can save this. Let me just move my zoom controls out of the way. So click the save button. Now, if I come back in here and I want to reread this command, and I'll start over. Now, if I do the stylized diagonal, I get a different mosaic tiling. So the funny story with this is that we were playing around with art ideas, and somebody said, "Hey, it would be great if somebody could do a Mona Lisa." I know a friend who had spent weeks trying to create a Mona Lisa version in triangles, and then it turned out that this was a very easy problem to do in Maple and could be done in about an hour. So the last thing I want to talk about is publishing to the cloud. And the way we do this is, well, I'll show you here. If you go to the very top right of your screen, there's a little bar here that shows you all the cloud things. And one of them is save to cloud, one of them is packages. So we can go to the packages list and it will show a bunch of user contributed packages. So let me go back to the my pack thing. And first thing I'll do is I'll turn this into a workbook. So under the palettes, there's a little tab there that's called workbook. And I can click this save as workbook button. And then it gives me that. So I'll call it MPack for fun. I'll call it MPack 2. And now we have a navigator because there's one worksheet in here. Let's redefine this package as my pack 2 so it doesn't get confused with the other one. And I'll execute that. So this time, instead of saving it into a separate memoA, I'm going to save it into this workbook file. And the way I do that is I can just use that same library tools command. Let's clear this out. Except instead of giving it a path to a file, I'm going to save my pack 2 to something called this : // So that saves it into the workbook itself. So a workbook is a .maple file, and it can work the same way as a .mla in terms of a repository for code. So I could distribute this .maple file, and if you put it in a place accessible by libname, then other people would be able to just with their package as well. So I'm going to do one more thing. I'm going to go to File and then New, and there's 4 new options here. I'm going to call the new document in Workbook, and you can see you get a new entry here, and I'll call this Intro. So I've got this worksheet. I can say my package. Well, let's make this text. And I'll put some text together to introduce this package and do some stuff. So once I've completed this, I can then go back here and click Save to Cloud. And I get a screen like this that says Publish to Maple Cloud. And I can fill in a title and give it a thumbnail if I want, etc. And then once I've filled that all in, I can click this Publish button. So then it will appear in this list. Actually, I think there's a vetting process. Somebody takes a look at it, and once it's approved, it then gets posted here to the Maple Packages repository. And then other people can fetch it and install it into their toolbox directory, and then they have access to it.